the next topic I wanted to talk about in connection-oriented Ethernet is the area of availability. So when you look at a mobile backhaul network, you want it to be highly available, probably much more so than other applications, because your network, you have people using it all the time, different times a day. You have machine-to-machine traffic, as well as end users that are using their cell phones. But because they're using it in a mobility environment, it's not like in a business. A business is open from 9 to 5, 6, or 7. People are using the network, and then the network is rarely used. So if you had an outage, in the middle of the night, it's not a big deal. But in the cellular network, it's used pretty much all the time. So when you look at availability, you want basically no single point of failure. And so you need to look at your fault tolerance when you're building your network. And if you take it from the bottom level, literally at your port level for your traffic coming in, by providing port protection using, for example, link aggregation, and then you have ports on a card, and those cards are protecting each other with maybe an active standby or active configuration. And then those cards fit into a network element that is protected either with protected power supplies or protected switch fabric. And then when you manage your network, you have an element management system or network management system. You want to make sure that if the database that understands the entire network, if the one network management system went down, the server went down, the network can continue to operate and you can continue to make changes to that network. And so you need a fault-tolerant management system. And then finally, for your software, so if you think about this always-on capability that you require for mobile backhaul networks, when you make software upgrades, either a patch or you're adding new functionality, you want to be able to do in-service software upgrades. So what that means is, as service is running, you make your software upgrade and you switch it over to the new software, and there's no impact to the user. So as from a user perspective, they don't see any impact. And now you don't have to schedule it. Normally you would schedule a maintenance window in the middle of the night. But again, in a case of a mobile backhaul network, because users are using the network all the time, you can't schedule it in the middle of the night and have the network down for 30 minutes because people need to use it 24 hours a day. And then the other thing is providing network protection using a technology called G.8031, which is linear path protection for Ethernet, and that gives you this 50 millisecond SONET-like protection. And then finally providing the fault management and service management to be able to troubleshoot the networks. And the sum of all of these in this triangle is you addressing all the way from the port level all the way up to the service level, and now that provides you with a complete fault-tolerant system. So just in closing on the CoE versus Ethernet over SONET, if you want to look at comparing the two different aspects of it, if you look at a number of different attributes, connection-oriented Ethernet and Ethernet over SONET for mobile backhaul, the high security, the deterministic QoS behavior, and the 50 millisecond protection are pretty much equivalent for both technologies. So that's a great plus. If you look at troubleshooting Ethernet OAM, that's a problem with Ethernet over SONET because Ethernet over SONET does not support Ethernet OAM. Now, guaranteed bandwidth is something that you get with SONET. You get these 50 megabit per second chunks of bandwidth in SONET, whereas in the case of connection-oriented Ethernet, you can bring that down to 1 megabit per second, and I'll cover that in more detail in a moment. And then now, when you have oversubscribed bandwidth, so sometimes you want to put some best effort traffic in addition to your guaranteed traffic. Ethernet over SONET can't support that, but connection-oriented Ethernet can. And then finally, for service multiplexing and efficient bandwidth utilization, I'll cover those in more detail, but Ethernet over SONET is not really optimized for that at all. And then if you look at the types of MEF services you can support, the connection-oriented Ethernet supports the full range of MEF point-to-point services versus Ethernet over SONET, which only supports an Ethernet private line service definition. So let's take a look at some of the Ethernet over SONET challenges in mobile backhaul networks using multi-service provisioning platforms, and then look at how connection-oriented Ethernet addresses those. So Ethernet over SONET, problem number one is that it does not support any type of service multiplexing or aggregation. So every Ethernet port that you put at a cell tower connecting a base station, maybe a 3G or 4G LTE base station, results in an Ethernet port at your mobile switching center. So it's a one-for-one relationship. Every port on the left side of the diagram results in a port on the right side of the diagram. So what you typically do is you put an Ethernet switch in there to aggregate all those ports. Well, that's additional CapEx and OpEx that you have to add in order to reduce the number of ports to a higher speed port. The second problem with Ethernet over SONET is the Ethernet over SONET bandwidth is dictated by the SONET container size, so the STS size, which is 50 megabits per second. So other bandwidth is wasted. So let's say at one base station you wanted to deploy a 20 megabit per second EVC, another base station you want to deploy a 10 megabit per second, and another base station you want to do 20 megabits per second. Well, because your minimum increment in SONET is 50 megabits per second, you're wasting all that extra bandwidth unless you're delivering exactly 50 megabits per second or N by 50 megabits per second to those cell towers. So the problem is now, in this case, with this example, I have 150 megabits per second of SONET bandwidth, and that's what the network, that's the way SONET works, or Ethernet over SONET, but I only have 50 megabits per second of really service bandwidth. So what I'm doing is I'm really wasting a ton of bandwidth here in my network. That's bandwidth that I have to charge the customer for because I need to recoup that because I can't use it for anyone else. Now, wouldn't it be better if there were a way I could reuse that bandwidth in the network and make it much more efficient? So if you look at connection-oriented Ethernet over SONET, one of the things you can do is it supports aggregation. And so what you can do is now take all of those Ethernet ports going to each of the base stations and aggregate it. This eliminates all of those extra switch ports that you need or another Ethernet switch to aggregate it. It does it right in the packet optical networking platforms that support connection-oriented Ethernet. The other thing is you can now multiplex those connection-oriented Ethernet over SONET connections into that same SONET container. So now in the previous case where I had to use 3 SONET containers, I now can use one 50 megabit per second container, squeeze those 3 services in, and I can get 100% bandwidth utilization over my SONET infrastructure. So as you could see, you could take because Ethernet over SONET today is probably the predominant technology for mobile backhaul, you can now take that technology, leverage that existing investment, and pack your backhaul traffic into there much more efficiently, and then get a better return on investment and be able to actually sell the bandwidth in much smaller increments to your wireless operator customers. So they might not want bandwidth in 50 megabit per second chunks. They might want it in boundaries other than that, and you don't have to charge them for 50 megabit per second bandwidth chunks. So if you look at the mobile backhaul evolution today, to kind of put this all in perspective, going from the cell tower back to the mobile switching center. So today you predominantly will have multi-service provisioning platforms, and you have some T1s and Ethernet that you're backhauling from the cell tower back to your mobile switching center. And so today with Ethernet over SONET, each of those Ethernet ports has to get mapped to a different SONET VCG, which wastes a lot of bandwidth. So as a future mode of operation, in step 1, what you can do is migrate those MSPPs into a packet optical networking environment, in which case those Ethernet ports now can be multiplexed together onto the same SONET VCG or SONET container, and that allows you to get much more backhaul efficiency. And then over time, as you evolve your network from having 2G, 3G, let's say LTE, you can eventually migrate all of your traffic over to an Ethernet over fiber, running connection-oriented Ethernet natively over fiber, eliminating the SONET layer completely as over time as you sunset those T1s. So I'm going to pass it over to Glenn. We're going to talk about the kind of a cost comparison of the present mode of operation and future mode of operation.
Well, thank you, Ralph. Ralph's done a great job at trying to explain some of the values of Ethernet over SONET, or the differentiation, I would say. So we start today, you got to keep in mind that everything is run Ethernet over SONET. In fact, that's even how we define some of the products. EPL from Verizon, and then I know other carriers the same way. It's defined in 50 meg chunks, and what we're trying to do is look at how that can be done different. So if you see the PMO on the left, just like Ralph said, in every case, if you're backhauling a individual circuit, it's going to show up as a port on some switch. And that means that you're constantly going to be talking about, and we did this generically, right? This is nothing Verizon specific. This is just how you build networks. And if you're going to do it with Ethernet over SONET and you're going to backhaul it, you're going to end up with individual ports on every one of those switches. And you got to carry and encapsulate it into SONET and then de-encapsulate it when you get to wherever the service edge is. And it's true for not just wireless backhaul, but for any backhaul for that matter, if it would be customer traffic or anything to that nature. So it does put you in a predicament where That edge switch has to have a lot of fan-in problems, and also the cost associated with that, because you do have all the IOF, interoperable facilities we usually call them, but what is all the SONET boxes underneath there? So that doesn't change, and it's a problem again for not only wireless backhaul, but anytime you've got a large concentration of Ethernet only type services. So if you looked at one of the ways to study this, and we do it for other service types where perhaps it isn't necessarily wireless backhaul, but you're doing aggregation. So you bring that back in that aggregation box, as we show on the right-hand side of the picture here, where you create really big single pipes that go into, and usually there's two. I mean, the picture is simplified, so you've got a working and a protect, but you create, say, 10 gig pipes going up into your service edge cloud, into that switch or router. So instead of 1 gig pipes, using link ag in many cases, or some other protection scheme, here you can go back to 2, working and protect, use link ag, but make them at 10 gig and reduce that fan in into the service edge router, which is the most expensive ports that we buy today. So what we're trying to do is push that further into the network. Now, we show this, again, generically built out as a series of underlying MSPPs to get you in that traditional IOF model. You could push that aggregation box to whatever point makes sense in the network. Sometimes it makes sense further out into the network, say clear out at the edge if you were fanning in a lot of Ethernet, for instance. Other times it would make sense, usually at that second tier. A lot of times that's where you've got a lot of aggregation that occurs, and or putting it right at the MSC, how it's kind of shown in this picture. But either way, the function is about the same. You're using it where you've got enough Ethernet to create large pipes, decapsulate it from SONET, create those large single pipes, and then carry that to the service edge cloud, as opposed to backhauling every single gig that would go all the way back to the service edge and the associated 50 meg increment that was related to that. Again, keep in mind, just as Ralph explained, if we sell a 10 meg service or a 20 meg service, or that's all the customer wanted to buy, we've got to create a 50 meg pipe through that interoffice network, through that interoffice facility network. Now granted, there's a whole lot of SONET already there, and that's why SONET's so prevalent. And we can also get it from everybody else. The panel before us did a great discussion about cloud computing and how networks need to work together. In most cases, if you order a circuit, especially if you're a large enterprise customer, we're going to somehow have to share that with somebody else. We may not have coverage everywhere, and you need to have that same service that you can order from everybody. And today that's either TDM services or it's Ethernet over SONET that you can get just about everywhere. If you want Ethernet only, native Ethernet, it's a little hard to get it ubiquitously across the United States or across the globe for that matter. Some countries are ahead. I've heard, if you were at OFC a couple weeks ago, a lot of folks have gone to Ethernet only, and they've really replaced their SDH networks completely, which is all well and good if you've got, again, a small network that you're working with and not as much embedded base. And if you can easily just do a cap and grow, but for us, cap and grow is a pretty difficult thing when you've got a very large network. So we've looked at different ways to try and do that, and the approach that we're taking is these multi-service platforms that allow you to do not only the wavelength switching, the TDM switching, but also now the Ethernet switching that can do this decapsulation from SONET and then aggregating into very large pipes.